3.3 is all about differentiating inverse functions. What do you know about an inverse function? Well, you know quite a bit about an inverse function. You know that y equals 3x minus 7 could be converted, or we could find its inverse function by simply exchanging the x and y's and solving for y. So I could get y, or 3y equals, add the 7 over, I'd have x plus 7, and then divide by 3, and I get y equals x plus 7 all over 3. This is the inverse function. So remember, the notation looks like y raised to the negative 1, which really means y inverse, not 1 over y. So that is inverse function. What else is true about inverse functions? Well, their domain and ranges flip-flop as well, don't they? So that little bit will help us guide us through derivatives of inverses. So confusing notation. Yeah, there is some confusing notation on here. Reciprocal, x to the negative 1 really means 1 over x. F to the negative 1 of x means the inverse function of f, of like original f of x. Let's write that. All right, 3 ways to say the same thing. We could say that g of x is the inverse of f of x. That would mean that g of x is equal to f negative 1 of x. And I also could write f of g of x is equal to x, as well as g of f of x is equal to x. When we were in pre-calc, we proved they were inverses by using composite functions and making each the composite of each other, and that should yield us an x in both cases. If that was the situation, then we knew we had inverse functions. So just, take a note of inverses, and there's multiple ways to say the same thing, which can make it confusing. Ordered pairs of inverse functions. So if you use the table, and my table is not showing up on this screen, darn it. If we use the table below, I can find out that f of 1 is 3. So then if I look at the inverse function evaluated at 3, it should have a y value of 1 because the domain and range flip-flop. If I look up f of 3 gives me negative 5. Oops. So then f inverse of negative 5 equals 3. Domain and range switch. So if I have x and y, it becomes y and x for the inverse function. That is a key understanding to have as we go forward too. So now the definition of the derivative of an inverse function. So d dx means take the derivative of f inverse of x, and this turns out to be 1 over f evaluated at f inverse of x. That's kind of confusing, isn't it? If I define g of x, I want to write the word if. If g of x equals f inverse of x, then I could also write this as 1 over f of g of x. Mainly what comes out of here is a new value, some value, right? This, if I put in 3, I get out negative 5. If I put in negative 5, I get out 3. So I've got to work with that. So there is the rule for it. You'll also see that if oh, darn it, get a derivative on there. I missed that. 1 over f prime evaluated at f inverse of x, which really yields the y value for the inverse function, which is the input value for the original function. So when I look at this, there is a reciprocal relationship going on, and the derivative of the inverse is the reciprocal of the original function, but evaluated at the y value of the inverse function, if that makes sense. You're going to see it come through. It is confusing. So we have this table below, and we have f and g and f prime at selected values. We know that g of x is equal to f inverse of x. What is the value of g prime of 1? So to find g prime of 1, I know that g prime of x is equal to f inverse of x. I'm just going to keep that in my head. G is really the inverse function to f. So g prime of 1 is equal to 1 over f prime of g of 1, or I could write that as 1 over f prime of f inverse of 1. Now, let's start with the inside and evaluate what is f inverse of 1. This is that domain range changing going on. So I'm going to have 1 over f prime f inverse of 1. Well, the inverse, this is the input value to the inverse, but the output value to the original function. Let's make a note of this. This is the output, or the y value, the output value of the original function. F of x. Because I've got to be able to use my table. I don't have a table that talks about f inverse. So I have to use my table to my advantage. So what I'm going to go find is the output value, right? This is an output. This is a y value when it's in the body of the table. The output value, then this is the input value to the original function. So the original function has a ordered pair of 2, 1. The inverse function, to it is a 1, 2 ordered pair. All right, so the f inverse of 1 becomes 2. That's the key to doing these. Now that ends up being 1 over, back to the table lookup, f prime of 2 is negative 2. And this comes from the table. And it looks like we get negative 1/2 for our slope. All right, then question 2 says write an equation for the line tangent to f inverse at x equals 1. Well, I just found the derivative at f inverse of 1 right up here, right? So I need f inverse of 1. I need its derivative. And I found that up above in part 1 to be negative 1/2. I also, for my f inverse of 1, f inverse of 1 gave me 2, the ordered pair, which means that I had an ordered pair of 1, 2 as the point on f inverse of x to the inverse function. You just got to kind of keep track of what perspective you're coming from. So y minus 2 equals the slope, negative 1/2, x minus 1. There's the tangent line. And then there's a, I thought there was a third question. Guess not. That is all I really have for notes, but I think, there is a number 3. I don't know if that's in yours or not, but oh, good. There's more. I am missing a page in my notes. So let me just continue on. Number 3, let g be differentiable functions such that g of 12 equals 4, g of 3 equals 6, g prime of 12 equals negative 5, g prime of 3 equals negative 2. The function h is differentiable, and h of x is the inverse of g for all x's. What is the value of h prime of x? Okay, so we know that h of x is the same function as g inverse of x. And they gave us lots of things to do, but they want us to find h prime of 6, which is like finding g inverse of 6, of 6. And we want its derivative, so I'm just going to make a mark on the outside because it gets congested on the inside of that function. This is equal to, go back to the definition of an inverse derivative. 1 over g is the original function. I know that because this is g inverse. G prime evaluated at h of 6. Now, I don't see too many h's for detail up there, so I've got to connect this to that this really h is the same thing as g inverse of 6. Now I hope I can use some data that they gave me in the description of the problem. G inverse of 6. Is there anything? G inverse of 12, G12, G3, G negative 3. Oh boy. Oh, right there. I missed it. Right there. The output for the original function, g, is 6, isn't it? If this is an input to the inverse, it's an output to the original. So I'm going to get, this is a g prime of 3. So use this. Now, 1 over g prime of 3, let's hope, there it is. G prime of 3 is negative 2, and we have our answer of negative 1/2. I'm going to go over here and say that g of 3 equals 6, so g inverse of 6 equals 3. That's one of those things that we knew and we had to use for right there to get that. And that all came off of that. Number 4, if f of x equals 3x cubed plus 1 and g is the inverse of x, what is the value of g prime of 25? All right, lots said there, right? So I got to digest it a bit. G is the inverse of f. That tells me that g of x is equal to f inverse of x. Now I've got a relationship between these, right? I know the relationship. Okay, so I've got that kind of digested. What is the value of g prime of 25? So let's go ahead and set up our thought process here. G prime of 25 is like asking for f inverse of 25's derivative. And that is a reciprocal relationship to the original function's derivative evaluated at f inverse of 25. If you just get used to this setup, that will help you immensely. All right, now I need to know 25 is the output to f of x, right? What I'm trying to figure out in my head, I need to find that f of some value equals 25. If I know that f inverse of 25 equals some y value, right? Well, then this becomes the output for the original function because x and y's do a flip-flop. How can I get this? Did they give me the information like they've been doing in the table in that last write-up? No such luck on that. but I do have the original function. So I'm going to use the original function and set it equal to 25. So I know y equals 3x to the third plus 1. Substitute 25 equals 3x cubed plus 1. Subtract 1, 24 equals 3x cubed. Divide by 3. Oh, I'm liking this. 8 equals x cubed. Cube root would be 2. Boom. We now have the original pair, 2, 25, don't we? This is the original function's ordered pair. Okay, so if I put into the inverse a 25, I get out a 2. And now I can finish this problem 1 over f prime of 2, right? Because 2 and 25 do a flip-floppy. What is f prime of 2? I need to find the derivative. Okay, so another little bit of side work. Derivative of f. That should be easy, it looks like. So we start out with f of x equals 3x cubed plus 1. Then f prime of x equals 27x squared. And I need f prime of 2. F prime of 2 means I'm going to plug in 2 to the x value. So I get 4. 4 times 27. Oh boy. 4 times 27. Well, 4 times 25 is 100. And 2 times 4 is 8. I'm thinking it's 108. Hopefully that's right. 4 times 25. That's a 25 plus 2. 108. All right, if I'm off, I'm off. 1 over 108. F inverse of 25. They really ask what's g prime of 25. I can connect all my lines of thought there, and we got it. That is a problem that really takes it from ground level all the way up, where you had to find a lot of stuff on your own. You may need to re-watch that problem. All right, using a graph or using a chart, using the chart here. G inverse, I think it's not established for us, but I'm just going to establish, this should have been some information given, that G inverse of x, oh, maybe I don't have to. G inverse is the inverse of G. Gosh, don't need to establish a darn thing there. Let me erase. Well, let's just get to it then. This is actually kind of straightforward. G inverse of 1, find its derivative, would look like the reciprocal 1 of G prime of G inverse of 1. To me, the hardest part is establishing that inside function evaluation for G prime. So G inverse of 1, I'm going to be in the G line, and I'm finding 1 as its output. If 1 is its output, -1 was the input. So this will now look like 1 over G prime of -1. And that's 1 over, now G prime of -1, here's G prime, -1, gets me a -1/5, which ends up being the reciprocal, or 1 divided by 1/5 is like 1 times 5 over 1, so I get -5. G inverse of +1 equals -5. The table work. G inverse of 1 turned out to be a -1, so G of -1 we know equals 1, right? That inverse relationship. The x and y's are reversed. I'm looking for a clear command, but I don't have it on here. Let's do of 3. It's not erasing nicely. Okay. Scrap that plan. Okay. G inverse derivative negative 3. G inverse of negative 3 equals 1 over G prime, reciprocal relationship, of G inverse of negative 3. Read our table backwards so that we can figure out what the y or the x value is to G of x. Oh, it's frustrating because my pen just doesn't work normal. Alrighty, here we go. G inverse of negative 3. Somewhere in this line, I'm hoping to find a negative 3. I spot it. That is an output to G, which means that this was the input. So this will update to a G prime of 4. I got to read the table backwards when I'm given an inverse of a function of a number. Now the easy part. G prime of 4 leads to negative 2. We get a negative 1/2. Hopefully you saw enough examples there that you can have success doing the worksheet. I'll have the answer key open on this because I suspect you might have some difficulties. Although it's all based on that same concept, you're going to have some chart work in there and just lots of fun. All right, good luck.